Right. Okay. Um, Good day. Let me start off by greeting you first. Tonight or today we'll be dealing with paper 2, November 2018. We'll be dealing with it's actually corrections, right? Now, okay, good. Let's get to it without any waste of time. Right now, 2.1 they say state Newton's second law in words. Right? You and I have agreed that when a non-zero resultant or net force acts on an object, the object will accelerate in the direction of the force with an acceleration that is directly proportional to the force and inversely proportional to the mass of that object. Now, acceleration is directly, rather, let's say, the F net, let me write a better E for you guys. The F net, right, is equal to, or let me not say is equal to, but is directly proportional to the acceleration. Similarly, the F net is inversely proportional to the mass, right? Now, you're gonna have to state it in words. I'm just trying to state it in formulas because I don't want to take much of your time. Basically, F net equal to ma. We proved that F net equal to ma by saying if you have F net change in time, then this will be equal to what? Your change in momentum, right? Now, F net will be equal to your change in momentum over your change in time. This is the rate of momentum, right? Or rather the impulse in simple terms. Now, momentum is m, change in momentum is m into v minus vo, taking vo to be your initial velocity and this v to be your final velocity divided by time. Now, m will be what? V minus vo, final minus initial divided by change in time. Then this will give you your ma. This is basically Newton's second law in simple terms. Now, that's good. 2.2 they're saying draw a free body diagram. They don't want a body diagram. So if you draw a free body diagram, you should have a force like this. Okay, firstly, for which mass? For the 8 kg block, right? Okay, good. Okay, looking by that, we have this force here, right? At a specific angle, right? Right, yeah, at a specific angle. Then we may also have another force, we may have another force like that, right? Take it that is a straight line, right? Now, also this is going to be another force here, and this is going to be another force, right? Basically, what they want is this tension, the normal force. This is what is 15 degrees here, right? And this is going to be your Fg, right? And this is going to be your friction force, right? Now, it's good. If you drew it like this, it's fine. Even if you didn't indicate the angle, you still right. Basically, they just want this. Let me check if there's no other color that I can find in here. I want a red color. I want a red color like this, right? Good. Basically, this is what they want here. This one, this one, this one, and this one. Then you get your 4 marks. Now, that's good. Let's go to the 2.3, right? In 2.3, they say when an 8 kg block reaches point B. Where is point B? Is this point, right? Now the angle between the string and the horizontal is 15 degrees, correct? And the acceleration is 1.32 meters per second squared, correct? Now give a reason why the system is not at equilibrium, right? Basically we know that okay, the main reason why it won't be at equilibrium, F net equal to 0, is because F net equal to MA. Then here you have what? It's an 8 kg. Then you say 8 by 1.2. We have acceleration of 1.2, right? Then F net is basically greater than 0, right? Now that is the main reason why this is not at equilibrium. Your F net is not equal, is greater than 0 because it has acceleration. That is, in simple term, what you can say, or acceleration is not 0. A is not equal to 0. Now let's go to this part here. They're saying use the what to calculate the tension of the spring, right? Now of the string. Remember they said calculate the tension. They did not say calculate the component of the tension, right? Calculate the tension of the string. Now you and I we have to really be careful on this one. Now we said F net equal to MA. Now which object are we calculating? This is a 2 kg. Is this object. Let's draw a free body diagram for that. Okay, good. Now we have this box. The force that is acting here is Fg, right? And another force that is acting here is going to be your tension. Now this tension is negative, right? Now we also have another force, or rather another vector to add here, which is going to be your what? Your acceleration, right? Now if there is a positive acceleration on this, it means that it correlates with Fg, because now if we look at this system here, we have tension, right? We have force of gravity. Now they're saying this object is going down. Let's read the statement. A block of right of mass 8 is placed on a horizontal rough surface. The 8 kg block, which is combined or connected to a 2 kg block by means of light inextensible string passing through a light frictionless, right, pulley, meaning this pulley does not have friction, starts sliding at point or from point A. Automatically when it slides here, it has acceleration of 1.32, right? It slides where? Downward, meaning that the force of gravity is doing more work than tension and is doing more work than friction. Now hence we have this acceleration here. That's good. Now if you and I are to deal with this, we can deal with it in simple term. We can say this is what? Fg plus tension, which is equals to MA, right? If we take Fg to be positive, we're going to take acceleration to be positive, because these two things are all going downward. They have to add each other, right? At the end of the day, Fg plus A is a combination, right? That's basically that, right? Now, okay, let's not get ahead of ourselves. Let's just deal with it and see where we're gonna end up, right? We know that Fg is what? Mg, right? Now what is tension? Remember we said this is going to be our negative tension, therefore we're going to replace this as negative tension. That is equal to your, what is the mass there? It's 2, right? Now what is the acceleration? 1.32, like that. Where did I put my calculator? Basically that's how we can deal with this, because we only have almost two forces that are acting on this 2 kg block, right, on this 2 kg block right here. Now, okay, good. This is the tension, right? Now it's fine. Now we have mg here. We said mg is going to be 2 multiplied by what? 9.8, right? It's going to be equal to what? 9.8 minus tension, then which will be equal to what? 2 multiplied by 1.32. Let's see if we'll get the answer, right? Now let's first simplify this. 2 multiplied by 9.8 is how much? It's 19.6. We have 19.6 minus tension, which is going to be equal to that. Now, okay, that's good. 2 multiplied by 1.32 is how much? Is 2.64. 2.64. Now, that's good. We can take this to the other side. We have negative tension, which is equal to 2.64 subtracted by 19.6. How much do we get? Negative 16.96. Good. Divided by a negative 1. Okay. We're going to divide by a negative 1. Why are we dividing by a negative 1? Because we want to get rid of this negative here. Eventually we're going to have what? T, which is equals to 16, right, 0.96. This is true because tension is never negative, right? Although we're saying it's doing negative work, tension is never negative. Now that's how we can calculate the tension, not the component of the tension, right? This is the tension that how we can calculate it. Now that's nice. Let's go to this one. So for this part here, right, you and I, for this part here, this is 1, right, this is 1, right, and this is 1, right? That's 3 marks for you. Now, okay, that's good. Let's go to 2.3.3. Calculate the kinetic frictional force, right, for the 8 what? Let's look at this. For the 8 kg block, right? Okay, good. On this 8 kg block, how many forces are acting there? We have this part, right? Now we also have this part. Where is it? We also have this part. Practically it's still the same, friction, right? And here we have what? Here we have positive tension, right? Now that's good. That is basically the forces that are acting there. Now for this 8 kg block, right? Okay, I want you to realize something. The reason why I did not calculate the component tension for this block is because there's no angle for the 2 kg. The angle is for this 8 kg block. Now for the 8 kg block, we agree that tension will not be just this, right? Now, what will it be? Remember, we said if this is going to be our tension, we're going to have what? The tension of X, right? And we're going to also have the tension of Y, the tension of the Y, or the Y component of tension. Now this is theta, like that. If we want to solve for theta using this, we're going to say for sine it's going to be sine theta equals to Ty over T. Now Ty is going to be equal to T sine theta, right? Now if we want to solve for the X component, which is the moving component, the horizontal component, okay, we can use cos, right? Now we can say cos theta equals to T at X divided by T. Now Tx is going to be equal to T cos of theta. That's good. Now it means with the tension that is there multiplied by the angle, right? Now we want to use this because we have an angle there and this box is moving horizontally. That's good. Let's get on with it and see how we can do that. Remember our formula is what? F net equal to MA, right? That's good. And we know that um, we have to this represents what, the T at x plus or minus the friction, which is equal to the MA, right? Now we can find the T at x because we know the formula there. Let's try to find the T at x quickly. T at x is going to be equal to the tension cos theta, right? The tension that we found here is true for all the tension that is here, right? Now we're going to add that value here. Let's see. All right, we're going to add that value there. For this one, we're going to say 19 point, it's 16. Let's go back. It's 16.96 cos of 15, right? How much do we get? When we calculate that, we get 16.382. So we can round it off to 16.38 Newton, right? We put it there. Here we have 16.38 subtracted by, what is the friction? We don't know what is our friction at that point. We don't know what is our friction at that point. So we're going to say minus friction, which is equal to, this is mass and acceleration, right? Basically, when we calculated F net at this point, how much did we get? We got 2.64, right? Now this is going to be our 2.64, right? That's good. We can take this to the other side and calculate and see if we will reach the answer. Oh, sorry. Acceleration, we're not going to use the 2 kg mass, so we're going to use 8 multiplied by 1 point, it's 1.32, right? 1.32, like that. Now let's see, 16.38 minus friction equals to 8 multiplied by 1.3, 8 multiplied by 1.32. How much do we get? 10.56, right? Now that means that friction, or negative friction, right, let's put another F here because I'm used to putting another F, will be what? 10.56 subtracted by 16.38. How much do we get there? We get negative 5.82. Negative 5.82, right? Divided by negative, you're going to have f of f, which is equals to 5.82. Now guys, there's no need to worry about this part here. We know that, okay, this ball acceleration is going downward, and we know that Fg is going down. We can take it as positive and leave it at that. Or if you're going to take Fg to be negative, make sure that your acceleration is also negative, right? I don't want to go through that. I just did it. We are done. Let's go to okay, this is 5.82 Newton to the left, right? To the left. We must give direction. Now let's go to 2.4. 2.4. What does the question say there? As the 8 kg block moves from point B to C, the kinetic frictional force between the horizontal block is not constant. Give a reason. It will not be constant. Why? Because the normal force changes, or rather the normal force decreases, right? That's another reason we can give. The other reason might be that the angle between the string and horizontal changes or increases, right? basically if we get to this angle will eventually increase, right? Because it's still on this surface, right? Yeah, so it may increase maybe to what, 32 or 30, right? Who knows, whatever angle that is there, right? Now that's basically the reason we can give, right? Now also, yeah, let's just leave it at that. Now the horizontal surface on which block B or sorry, to which block the 8 kg block is moving is replaced by another horizontal force, right, made from a different material. Will the kinetic frictional force calculated change? Choose the answer. Obviously it's gonna be a yes, right? Why a yes? Because the friction force or the coefficient of the friction force depends on the nature of the surface it is in contact with. It depends on the nature of the surface it is in contact with. I'm not gonna write those down. Basically, yeah, if you did not mess up on the signs, you would have gotten your marks, right? Yes, that's good. For this one, if you haven't, yeah, that's good. That's good. Anyone with any question, feel free to ask on the comment section, right? And you'll be helped. Right, thanks guys.